In this video, we'll be talking about linear inequality. Here is an example. Y equals 1/2 x plus 1. In order to do linear inequalities equations and graphing them properly, we need to first know how to graph a line of a linear equation. In this example, it's y equals 1/2 x plus 1. So this is more like a little review before we start going into linear inequalities. For those of you who doesn't understand how to graph a line, 1/2 here is the slope of the line, and the 1 here is the y-intercept. So you will start at 0, 0 from the graph and going up on the y coordinate, and that's the beginning point. Then what you want to do is going up 1 from the slope, then going 2 toward the right on the denominator of the slope. Then you will connect the two dots together to form this line. So the two dots that we have come up with were this one and this one. And when we connect the two lines together, we get this. So that's how you would graph a line. In a linear inequality example here, we're trying to figure out whether the points lie on a graph is equal to, greater than, or less than to the equation. What you see here is a linear equation, y equals 1/2 x plus 1. This is the line that is indicated on this graph here. Now with the linear inequality, the equation will look something like this. Y is greater than 1/2 x plus 1. Or y is less than 1/2 x plus 1. And the points that currently lie on this graph will only satisfy one of the two scenarios, if it's greater than or less than. So what we can do is we'll first take the 6, 6 coordinate here, and we're going to go ahead and plug into the first linear inequality equation. Okay, so we have y 1/2 6, because x is 6, plus 1. And y here is also 6, so it's going to be 6 greater than 1/2 times 6 plus 1, 3 plus 1. So this one, 6 is greater than 4. And the answer would be true. 6 over 4. 6 is greater than 4. Okay, now we're going to try the next one. This is the coordinate 3, -5. So -5 is less than 1/2 times 3 plus 1. -5 is less than 3/2 plus 1. -5 is less than 1 and 3. So the answer for this is true. So on the question that you will see on either your homework or test, they would give you this equation and expect you to plug in the coordinates, the x value and the y value, and determine whether that comes out to be true or false. Therefore, we could say that the top portion of the linear inequality would be y greater than 1/2 x plus 1. And the bottom portion would be y minus 1/2 x plus 1. Now, if the question asks you to shade the graph, then what you want to do is you want to shade the bottom portion. If the question that was given to you was y less than 1/2 x plus 1. Now, vice versa, if they were asking you for graphing y is greater than 1/2 x plus 1, then you want to go ahead and shade the top portion. And this portion will be y greater than 1/2 x plus 1. Now, if the equation is greater than or less than, the line that we have in between should be dotted, because that means that any of the value that's on the line is actually doesn't apply to the equation. So the line would have dotted line like this. My drawing isn't very good, but I'm sure you can imagine that you wanted to make sure that the line would be dotted rather than a straight solid line. However, if the linear inequality equation is y equals greater than if the linear inequality equation is y greater than or equal to 1/2 x plus 1. When that happens, then the line in between would be a solid line. Same thing with the bottom portion. If it's y less than or equal to 1/2 x plus 1, you will leave the line solid as well. That means that the value also on the solid line is also applied to the equation. Now, some of the easier examples, such as y greater than -2, you would simply graph it just like how you would graph on the line, but you want to shade the portion that's greater than that line on this graph. So y is greater than -2 means that it's a straight line through the middle. And any portion that's greater than -2 will need to be shaded. That it would be basically everything that is greater than that negative, the line on from the y-axis. Okay, so what I have here would be y is greater than -2, the portion that I have in yellow, and what we want to do is change it so that the solid line is actually dotted. Okay, so that would be y is greater than -2. Then again, if the question was if the question was y is less than -2, then you would do the same, but then you will want it on the opposite side of this line. So the green portion here is y less than -2. So this is how you would solve linear inequality equations, and how you would use the coordinates from the graph to determine whether your linear inequalities equation is true or false. Thank you for watching.